In this podcast, we will introduce you to the course content on present and future prospects in energy technology, a course that we teach within the selection of the FITech Network University. This course shall provide you with up-to-date knowledge on the state-of-the-art and future prospects of the selected themes under energy technology. We will go through the most recent work in the sector of distributed energy generation. Also, we will give you an outlook of the companies in the energy sector in Finland. The course is suitable for you if you are a student interested in renewable energy generation systems. Also, if you are a professional or adult learner and want to gain knowledge on new developments in this field, you are welcome to join us. The knowledge gained during the course will help you understand and evaluate renewable energies and enables you to look at sustainability issues in energy production. We expect you to have basic knowledge of physics and chemistry. During the course, you will develop critical thinking and your analytical skills, and you will learn or practice writing skills. We are a group of Finnish and international researchers in the School of Technology and Innovations at the University of Vaasa, researching in the area of renewable energies. Each of us is specialized in one or more areas of the topics that we will take you through. Mankind is at a point where it is important to think of the ways how we live now and want to live in the future. Since the Industrial Revolution, an ever-increasing amount of fossil fuels has been used to cover our energy demands. Burning fossil fuels has led to an increasing amount of carbon dioxide and other greenhouse gases in the atmosphere. Greenhouse gases have led to an increase in global temperature, and they are threatening to cause problems for life on Earth through changes in the environment. Moreover, fossil fuel sources are not renewable and are also expected to be depleted within near future. At the level of the European Union, it has been aligned that the use of renewable energies shall be increased to 32% by the year 2030. And Finland has set the goal to reduce its greenhouse gas emissions by 80% until 2050, as compared with the year 1990. In order to reach these goals, research and development into renewable energy systems must not stop, and sustainability is the key issue. Since using fossil fuels is not good for the environment, what alternative technologies do we have to produce energy? In this course, we introduce you to existing technologies to generate renewable energy and give you an overview of future technologies. We will cover areas from bioenergy, geoenergy, solar energy, and wind energy. What are the technologies? How do they work today, and how are they developing? And perhaps more interestingly, do they provide us with enough energy to cover our demands? Bioenergy. Burning wood is certainly the oldest way that mankind has used bioenergy, and it is still used most widely in the world. But biomass, which is an organic material, has also been transformed into biofuels that are more dense and have a higher energy content than the source material. There are many conversion technologies available for biomass of slightly different compositions: pyrolysis, transesterification, and fermentation, just to mention a few. With the help of different processes, organic material can be turned into biogas, and biofuels such as biodiesel, biohydrogen, and bioalcohols. Bioenergy is renewable because biomasses like crops and forests grow back if only we let them. And all plants bind carbon dioxide from the air in the process of photosynthesis. But they also release carbon dioxide during respiration, natural decay, and combustion of the biofuel. However, bioenergy can provide the opportunity to keep carbon dioxide in a loop between the atmosphere and being bound into organic material. Nevertheless, it is important to know how the biomass has been grown, harvested, transported, and transformed before one can say whether a biofuel is produced in a carbon-neutral way. Also, if cultivation of biomass or production of biofuels competes with food production, is this sustainable? More and more research is being done with materials and organisms that do not compete with food production for area. Already, residues and wastes from various industries are being used to produce commercial fuels of high quality. It is important that availability of these fuels is increased in the future. Microalgae are another example of a not-so-usual biomaterial. Microalgae are living in all kinds of different waters: freshwater, seawater, natural waters as well as wastewater. They are microscopically small one-celled organisms that can form colonies and become visible to the human eye only when they become abundant in numbers and then color the water. Microalgae bind carbon, either organic or inorganic carbon, when growing and multiplying. Like other living organisms, microalgae produce carbohydrates, proteins, and lipids. Microalgae lipids can, for example, be transformed into biodiesel, and the carbohydrates into alcohols, or the microalgae biomass can be used to produce biogas. When cultivating microalgae, waste streams such as flue gases and wastewaters can be utilized. It is known today that many fuels can be produced from microalgae compounds, but there is no profitability yet because the price of fossil fuels is low, and renewable energy's profitability is generally compared to fossil oil. Microorganisms are also the focus of research in microbial fuel cells and electrohydrogenesis. While these technologies work in the laboratory, there are still challenges to scale them up for pilot and industrial use. Solar energy. Solar energy can be used in many different applications, and the goal with these is to provide self-sufficiency in energy production and to reduce carbon dioxide emission. When using solar energy, less fossil fuel is needed to produce electricity and heat. The possible uses may be one-family houses or even whole districts. A low-end application of utilizing solar energy might be simply a dark surface or shiny metal surface. It is well known that a darker surface absorbs more energy than a lighter one. This can be utilized, for example, by using an asphalt surface as heat collector or painting a surface black. A dark surface is then allowed to heat up, and this heat is either collected or directly used for an application. The shiny metal surface can be used to direct the solar light to the target to heat, such as a cooking pot. Two commonly known applications are solar panels and solar collectors. These are high-tech applications, but many simple and cheaper options are also available, like mentioned before. Solar panels produce DC electricity, which is available for use during daytime. If electricity is needed for later use, a battery system should be employed. The efficiency of solar panels is improving all the time, as this is an intensely studied area. However, solar panel systems use some rare minerals, and there can be problems in production and recycling of panels. Solar collectors collect heat and typically also store heat inside a thermal storage system for later use, such as, for instance, a water body or a borehole. There are several types of solar collectors which utilize different heat collection fluids and methods. Geoenergy. Geothermal energy is thermal energy generated and stored inside the Earth. This energy originates from the original formation of the planet and from the radioactive decay of materials. Instead, geoenergy is the radiant energy from the sun, which is partly absorbed by ground surface. There are also some parts of geothermal energy which can be included in the term geoenergy. And it can be said that geoenergy is available everywhere. The climate in Finland is rather cold, and the heating of houses is essential during more than half of the year. Urban energy is a potential alternative when thinking of thermal energy solutions in towns. There's a huge energy need in towns and cities, but also a huge potential of energy contained in the built environment. Urban areas gather heat due to buildings, traffic, pavement, and the lack of flora. This urban geoenergy could be harnessed better in the future. Also, waste and wastewaters must be noticed as an energy source. By utilizing this kind of local energy, one can mitigate climate change. Instead of burning oil or coal and releasing carbon dioxide and other greenhouse gases, it is advantageous to utilize the energy that is naturally generated from the environment in order to produce heating. Hybrid energy systems could be built based on different urban energy sources. At the moment, there is a huge project of an industry-level geothermal energy plant going on in Espoo. With the help of over 6-kilometer deep boreholes, the district heating network will cover as much as 10% of Espoo's heat energy demand. If the project is successful, the future will be bright for this technology. So-called semi-deep boreholes, about 2 kilometers deep, are another interesting and new approach in the Finnish geoenergy market. One hole can cover the heat demand of up to 4 apartment houses. Heat energy storing is a growing trend in the geothermal energy sector in Finland. Borehole thermal energy storages or underground thermal batteries have many new research pilot cases going on and upcoming. Seasonal energy storing for both heat and electricity will open up new opportunities as part of sector coupling in the energy markets. We have come to the end of the podcast on present and future prospects in energy technology. If you are interested in the course content, please join us. The next course will be held in spring 2021. Go to fitech.io to find more information.